Well, hello 2D. Today's topic, we're still looking at primary trig ratios, but our goal today is to learn terminology related to applications and application questions and be able to effectively use trigonometry to solve problems. Now, the biggest obstacle for using trigonometry to solve problems is to know the terminology and be able to draw the diagram. So let's have a look at what some terminology is. We're going to talk about angle of depression and angle of elevation. Now, depression, just like most of the words that, most of the ways we use the word depression, depression means down. You know, if you're feeling depressed, you're feeling down. If you depress a button, usually you just say press, but if a button is depressed, it means that it's been pushed down. So an angle of depression is an angle measured down from a horizontal line to the line of sight between objects. And then elevation means up. An elevator, if you get elevated, you go up. An elevator goes up, well, also goes down, but elevate means to go up. So this is an angle measured up from a horizontal line to the line of sight between objects. So if you see the words depression and elevation, you know that you have to have a horizontal line to start with. If there's no horizontal line present, you're going to have to put one in. So let's take a look at what that means here. So here's one. We're just going to draw the diagrams. We're not going to do any math calculations on this one. So this says, example 1, a helicopter spots a campfire at an angle of depression of 15 degrees. Now the first thing we can do for this is put on the whole idea of that an elevator spots a campfire. So the first thing you have to do is put on the line of sight from the two objects. The next thing you have to do is decide where the angle is being measured. So this says a helicopter spots a campfire. So the angle is being measured from the helicopter. And so you have to have a horizontal line go out from the helicopter. So you have to have those two things on before you can put that 15 degrees on the diagram. So you need a line of sight between the thing that's looking and what it's looking at. And then wherever the angle is being measured from, you have to have a horizontal line. Okay? And I often like to have the horizontal line be a dotted horizontal line, just to show that that there's really no line there. The line of sight is a real thing. The horizontal line is just it's horizontal. It's parallel to the surface that you're looking at. So now let's mark on the 15 degrees. Now it goes from the horizontal line down to the line of sight. That is our 15 degrees. Now I've marked all of that on. We have no idea what we're trying to calculate here. We're probably going to try to calculate the distance to the fire, or we're going to try to calculate the height of the helicopter or something along those lines, that there's more to put on this diagram. But right now we've marked on the angle of depression that goes down from the horizontal line. So let's take another one. This says Caitlin looks up at an angle of elevation of 75 degrees. So let's take a look. Caitlin, this is Caitlin here. She's going to look up to the top of the CN tower. So there's her line of sight. And since it's Caitlin doing the measuring, where the angle is being measured from needs a horizontal line. So we need to go out from Caitlin's eyes with a horizontal line. Sometimes we disregard this distance in here and we would just treat Caitlin as a point, but a lot of times things that we're measuring, we need to take the height that measurement is being taken into consideration. So we're going to take that into consideration here. And then where is that 75 degrees? Well, this is an angle of elevation, so it has to go from the horizontal line, from this horizontal line, up to the line of sight. And it's this angle in here that is 75 degrees. Okay, so now that we've got that straightened around, let's take a look at a question. This says a surveyor measures the angle of elevation from his eye to the top of the tree to be 73 degrees. So this is an angle of elevation, so we're going to put on those lines. He's looking at the top of the tree. and it's him that's looking. So we have to put a horizontal line over. Now what we're going to do, we've created this triangle here. So we're going to be able to calculate this height of this triangle. But then we are going to have to put on how tall he is. So let's do that. So his angle of elevation to the top of the tree is 73 degrees. He knows his eye height is 162 centimeters and that he is standing on level ground 7 meters from the tree. Now level ground is kind of important here. This has to be kind of level ground, otherwise you're going to get kind of a bad estimate. If he's standing on a hill over here, that's not going to be very useful. So he's 7 meters from the tree, and he knows his eye height is 162 centimeters. I'm going to change that into meters right now. So this distance here is 1.62 meters. And we're asked how tall the tree is. So this is a right angle triangle because vertical height meets horizontal level. So we're going to say, take a look at, let's change the color. Here's my angle. This is the opposite side. This is the adjacent side. And this is the hypotenuse. Now we're being asked to find the height. I use a script H for that. We're being asked to find the height of the tree. So we don't need the hypotenuse. We need the opposite side, and we've been given the adjacent. And opposite and adjacent is tan. So I'm going to say T equals opposite over adjacent. Tan of 73 degrees equals H over 7. And then we can treat this as if it were over 1 and use cross multiplication. So H times 1 gives us H, and 7 times tan of 73 gives us 7 times the tan of 73. And then you're going to pull up your calculator. Let's find my calculator. There's my calculator. I'm going to pull up my calculator and type in 7 times 70. Oh, hold on. This is the calculator. Oh, clear. This is the calculator that works forward, so I have to press tan first. So 7 times tan of 73. And enter. 22.9 if I round that. And we usually want to round to 1 decimal place. So 22.9. 22.9 meters. Now, the chances of that 0.9 being completely accurate are pretty slim, depending on exactly what the surveyor is measuring with. So measurements are never completely accurate, so all we're ever doing is getting an estimate. So let's put in the total, because we have to add in his height. So the total is going to be 22.9 plus 1.62. And let's just add that 1.62, 1.62, and we get 24.5. We're not going to worry about all those little decimal places because it's really not that accurate. So 24.5 meters. So therefore, the tree is 24.5 meters tall, approximately. Let's put our dots on there. All of these are approximate values. Whenever you're dealing with measurements, it's always approximate values. Your measurements are only as good as the instruments you're using to measure with, and they're only as good as how careful you are when you're taking those measurements. Okay, so here's another one. This says a guy wire holds a hydro pole in an upright position. So this thing here is what we mean by guy wire. It is attached to a pole at a location 0.5 meters from the top. So we're saying that this here is 0.5 meters and makes an angle of 63 degrees with the ground. So this didn't actually have an elevation angle or anything with it. It told us that
the guy wire and the ground make a 63-degree angle.
So there's not even a lot of terminology to use in this one. If the guy wire is 6 meters long, so we know that the guy wire is 6 meters long, how tall is the pole? Okay, so we've put all of that information on this diagram, and hopefully you could have drawn a hydro pole and put the information on it if that hadn't been there. Okay, all you would have to do is draw the pole and draw the wire that's attached almost to the top. This one's a fairly easy diagram to do. Now we want the height of the pole. So we know this top piece is 0.5, but we don't know what this piece is. So that's what we're going to have to find. Let me switch my colors here. I'm going to circle my 63 degrees. This side is opposite, and here's the right angle. So this side is the hypotenuse, and this side over here is the adjacent side. Now this time we have the hypotenuse, and we're being asked to find the opposite side, so it's the adjacent side that we don't need. So if we take a look at SOHCAHTOA, if you need to do this every time, feel free until you get a little bit used to the figuring these out. So we need to use opposite and hypotenuse. So if we look through it, the one that has opposite and hypotenuse, and cos has hypotenuse, tan has opposite, but sine has both opposite and hypotenuse. So we write S equals O over H. And then we go sine of 63 degrees equals H over 6. Now try not to confuse the two H's. Notice that I put a script H on here and not a script H on here. Use the H. Sometimes I use capital letters for opposite, adjacent, and hypotenuse, just so that you don't see that confused with the variables that we're trying to find, because I do usually use an H for height. Now I'm going to switch colors here because we're going to pretend there's an over 1 here and do our cross multiplying. Or you could say we just need to get rid of 6 on this side and we're going to multiply both sides by 6. It's up to you which way you think about it. So H times 1 is H, and 6 times sine of 63. We're just going to write 6 times the sine of 63. And then we're going to pull out our handy dandy calculator and do 6 times the sine of 63, which is 5.3. And that is approximate. So 5.3 meters, but that's not the total because we still have this little bit at the top where the guy wire was attached to the top of the pole. So we're going to do the 5.3 that we've calculated plus the 0.5, which is 5.8 meters. And we're going to leave this dot above the equal sign that means approximately because it's a measurement. And of course, for all application problems, we really should have a therefore statement. So therefore, the pole is 5.8 meters tall. And that will do it for this video today. Give the applications a try and hope and ask me if you have any problems. Okay, thanks. Bye.